So, in the world of AI, there's this massive arms race going on, right? And for the longest time, the thinking has been super simple. Bigger is always better. More data, more computing power, more parameters. But what if that's not the whole story? What if the next giant leap forward for AI actually comes in a much, much smaller package? That's the big question we're digging into. For years, the philosophy has been all about scale. We're talking models trained on trillions of words with more internal knobs and dials or parameters than you can even imagine. And yeah, it's an incredible engineering feat, but it comes with a staggering cost. Now, though, a new challenger is showing up and proving there might be a totally different and frankly, a smarter way forward. So, on one side, you have the Goliaths of the AI world. They're built on one thing: sheer brute force scale. But on the other side, you've got a completely different philosophy, and it's being championed by Microsoft's 5 family of models. Their bet is that it's not about size, it's about being smart. It's about efficiency, clever design, and really, really high-quality data. It is the classic David versus Goliath story, but for the age of AI. All right, so let's meet our David. Its name is, I know, a bit of a mouthful, Phi 4 Reasoning Vision. But what it is a super compact model that can understand both text and images. And its entire mission is to prove that you can get incredibly powerful AI reasoning without needing a data center the size of a city to run it. And look, this isn't just some marketing hype. The researchers who built it say it right in their report. It all boils down to 2 key things: careful architecture and rigorous data curation. In other words, this has nothing to do with brute force. It's all about being strategic, being clever, and being incredibly efficient. So you're probably asking, okay, how on earth does a smaller model even stand a chance against these giants? What's the secret sauce here? Well, it's not magic. It's more like a recipe, and it's built on 2 key ingredients: insanely high-quality data and a really clever, efficient design. Let's break down how they pulled it off. First up, the data. Instead of just, sucking up the entire internet, warts and all, the 5-4 team acted more like gourmet chefs. As you can see from this mix, they created this perfectly balanced diet of different data types. You've got visual questions, math and science problems, web data, but all of it was meticulously filtered and cleaned. They even used other AIs to help generate better training material. It all comes back to their main belief. It's data quality, not just sheer quantity, that really moves the needle. Okay, so the second ingredient is the model's blueprint. It's architecture. It uses this really slick design to combine what it sees with what it reads. Now, instead of forcing the AI to process every single pixel in an image at once, which is incredibly expensive, by the way, it has this little component that first summarizes the image into key ideas. Think of it like a quick cheat sheet of what's in the picture. Then, those little summaries get fed into the language part of the model. It's a super efficient shortcut that gives you amazing understanding without a huge computational bill. And this all comes together in a very methodical 3-step training process. First, they get the vision and the language parts on the same page, speaking the same language. Then comes the main event. They train the whole thing on that incredible, high-quality, gourmet data we just talked about. And finally, they do a last round of fine-tuning for special skills like reading long documents and, of course, safety. It's like a focused, expert curriculum for building a smarter AI. So that's the theory. It all sounds great on paper, right? But the real proof is in the pudding. So what can this lean, mean, efficient model actually do? Well, let's get to the good stuff, because the examples from the report are pretty mind-blowing. I mean, just check this out. This is the kind of stuff that's actually useful in day-to-day life. It can look at your travel photo and write a personal, interesting caption. It can read a confusing receipt and figure out how to split the bill. And maybe my favorite, it can finally decipher those completely baffling laundry symbols on your clothes. Now that is genuinely useful AI. But it goes way, way deeper than that. Look at this example. It's analyzing a handwritten math problem. Now, it doesn't just spit out the right answer. No, it's way smarter. It actually finds the specific sign error the person made in their calculation, explains the mistake, and then gives the corrected solution. That's not a calculator, folks. That's a math tutor. And this is where things get really exciting for what's next. The model can understand and interact with what it sees on a computer screen. Someone asks it, "Where do I click to play music?" And bam, it outputs the precise pixel coordinates of the Spotify icon. This kind of detailed understanding is a massive building block for AI agents that can actually use our software for us. The future is here. These examples are super impressive, for sure. But the real knockout punch? It's in the data. This is where we see exactly how Phi 4 is punching so far above its weight class. It proves that being efficient isn't a compromise. It's actually its greatest advantage. Okay, get ready because this is the big reveal. These charts pit accuracy against how much it costs to run. Now, what you're looking for is that top left corner. That's the sweet spot of high accuracy for low cost. And just look at where Phi 4 is sitting. It is right on that optimal line. It's getting accuracy that rivals models that are way, way bigger, while, and this is a direct quote from the paper, requiring 10 times or more less compute. It's faster, it's cheaper, and it still absolutely delivers. And just to really drive this point home, let's look at a head-to-head matchup on a really tough math test. Phi 4, at 15 billion parameters, scores a very solid 75.2%. A competitor that is more than double its size, at 32 billion parameters, scores an 81.8. I mean, they're in the same ballpark, but as we just saw, Phi 4 gets there using a tiny fraction of the resources. That is an absolute game-changing trade-off. So let's step back for a second. What does all of this actually mean? Because this isn't just a cool story about one clever model. This research is pointing towards a fundamental shift in how we build artificial intelligence. It's about way more than just climbing leaderboards. This could have huge implications for the entire field. So why does this matter so much? Well, first, accessibility. An AI this powerful could one day run on your laptop or even your phone, not just in the cloud. Second, sustainability. Less compute means a smaller energy footprint, which is a big deal. But maybe the most important thing is democratization. When state-of-the-art models get this efficient to build and run, it empowers so many more people, researchers, startups, developers, to innovate and build the future. We started all this by asking if size is all that matters, and I think the story of Phi 4 gives us a pretty powerful counter-argument. It shows us that true intelligence might be a product of smart design, not just sheer scale. It proves that being smarter, more focused, and more efficient could be the real key to unlocking the next wave of AI innovation. And that leaves us with one final, very provocative question. Is the future of AI actually smaller?